Our project is on the weather on Mars. Mars, just like the Earth, also has 4 seasons. However, they're almost twice as long. This is because Mars's orbit is roughly twice as big as the Earth's. Also, Mars's orbit is not as symmetrical, so it can cause the southern hemisphere to have much harsher seasons. During the winter, the temperature can drop all the way down to negative 140 degrees, which can cause polar ice caps to form, which start melting in the springtime. According to the ESA, depending on the season, clouds can form in either the northern hemisphere or around the equator.
Mars has a very thin atmosphere. It's made up of 95% carbon dioxide, and its pressure is less than 1% of Earth. That's the reason it doesn't keep much heat, and it has extreme temperatures, such as negative 80 Fahrenheit on average. And even the highest it will get is 70 Fahrenheit by the equator during the day. And the nighttime can get all the way down to negative 195 Fahrenheit. It has the largest dust storms in the solar system. Sometimes it covers the entire planet. It shows in the bottom right picture. They can last for weeks, impacting sunlight and temperature. And then a fun fact would be Mars's thin air means no rain, water vapor freezes or sublates, forming frost and clouds instead.
NASA has placed four instruments on Mars, two on the surface and two in the orbit. The two on the surface are Perseverance and Curiosity, and their main function is to measure weather patterns. They can also measure temperature, humidity, wind, speed, and direction. These wind sensors also measure the amount and size of dust particles in the atmosphere, helping scientists understand the dust cycle and its impact on the weather. The two orbital ones, the MAVEN was placed on September 21st of 2014, and the MRO was March 10th of 2006. The MAVEN has a specific role to measure the compounds of CO2, N2, and H2O. By studying this, scientists can understand the history of Mars' atmosphere, climate, liquid water, and planetary habitability. The MRO's responsibility is to study Mars from an orbital perspective while mapping the surface, analyzing minerals, and monitoring the weather, studying climate, and studying the terrain. Without the use of these instruments on Mars, scientists would not be able to study the weather as well.
Scientists have discovered evidence of ancient river valleys and lake beds, along with minerals that form in the presence of liquid. This evidence suggests that Mars once had liquid water on its surface, and water is one of the key ingredients to life. In past conditions, that atmosphere was thicker, making Mars have more of an Earth-like climate with a greenhouse effect, which is how they think that the water was allowed to exist on the surface. With there being past water, scientists have discovered, and they think that there's a high possibility that microorganisms could have lived under this ice layer. Similar pools of water have been found on Earth within the different layers. They hold algae and bacteria, which receive energy from photosynthesis.
And here's our sources.